Hi there, welcome to Lecture 13, Transhumanism. I'm having to record this at home because the lecture in class didn't record, which really pissed me off. The reason it didn't record is Zoom changed their interface and they moved the record button. I clicked on the record button and it didn't record. I apparently had to choose another option. Uh, if I got a little HCI thing here, if I got caught out by that yesterday, how many hundreds of thousands of other people got caught out by that on the new interface yesterday as well? Uh, Drives me crazy that when people do things like this. But that's my rant done for now. Before we get going on this new topic, Module 5, I hope you all had a good spring break. Obviously, we haven't been in class for 10 days, so lots has happened. I've tried to limit it to just some of the big things that happened. So I'll show you a few things that went on over the last few days in the world of AI. The biggest event was NVIDIA held their global technology conference in California and made a whole bunch of announcements. I mentioned before that they had these new Rubin chips, which were way faster than anything else, designed specifically for AI. And they previously announced four of them. They announced at the conference there are seven chips in this series. There are some that are even more powerful than we'd seen before. But they announced what's called the Vera architecture for these Rubin chips. And the kind of speeds they're talking about are just crazy. I mean, we're talking about scaling up these big dense data centers. They say their new chip architecture, their new rack system, their new connection system, their new chips will make inference 30 times faster, training four times faster. They're 25 times more energy efficient and process data 18 times faster. I mean, this exponential thing is just getting out of hand. We're growing at faster than exponential right now. Um, they also announced Nemo Claw. We haven't really got onto these claw things yet. We'll do that in this section when we talk about AI agents. But the biggest AI agent at the moment is OpenClaw. And I just spent part of spring break learning about OpenClaw so I could teach you about it because it didn't exist a few months ago. So I've just learned this and already it's being replaced by other things. This Nemo Claw looks way better than OpenClaw and it's far more secure. So who knows? As I say, you just can't keep up with stuff these days. Um, they also announced DLSS 5. Those of you who play video games a lot will know what this is. It's an AI upscaler for video games. It makes games appear at higher resolution than they really are. And this showed some quite astonishing kind of demos of this. There's a lot of controversy about it at the moment because apparently, if you just slap it into an existing game, it doesn't work that well, and games have to be specifically designed for it. But yeah, a big advance in video game technology as well. You can see the kind of difference there. The previous game rendering on the left, and on the right, this far more highly realistic kind of rendering on the right. Just look at the hair, you can see the kind of rendering that DLS SS5 achieves. It's all ray trace stuff. Fascinates me, but I'm a video game guy. Uh, so what was the big outcome of NVIDIA's conference? They announced that they are going to have a turnover. These new systems, they expect to earn $1 trillion in the next year from selling these systems. As I said, they've already sold most of them. OpenAI and Meta and Google have already bought up most of them. So, yeah, $1 trillion. It's beyond comprehension how much money that is, really. And this is one company. Uh, OpenAI have just got over $150 billion in funding, and they just announced another $10 billion in funding from private equity firms over the last couple of days. OpenAI also announced something quite interesting a few days ago. Their biggest project at the moment is on building AI for science. We'll be talking quite a lot about how fast science, physics, chemistry, material science, genetics and medical stuff particularly is advancing because of AI. That science is exponentially advancing as well. Um, and OpenAI have announced this is going to be one of the main thrusts of their future development is developing AI for science, which is interesting because Google announced that a year ago that it was that they were doing this with they were building this idea of the co-scientists into Gemini 2. Of course, we're now on Gemini 3 with Google, but yeah, but OpenAI have announced this is their big thing now. Um, Google announced a few other products over the last 10 days. One of these is embedding 2. Google embedding is used by enterprise scale large corporations to put agentic AI into their organization. The second version of this does a lot more with multimodal support, so web media, videos, audio, all of that, real-time environments are now more integrated into these agentic AI systems. So uh, Google also announced this tool, which I only read about a couple of days ago. Now, those of you who are on the HCI program will be familiar with things like Figma, which we use to prototype software as we're developing web pages and software or mobile apps. Um, This, and we often talk in the HCI class about the role of graphic designers and interface designers, the role of UX people and how they overlap. This is Google have just announced Stitch, and it's basically we have coding where you don't need to know how to code to build an application. We now have vibe design where you don't need to be a graphic designer or a designer. This does the job of graphic designers and interface designers. It looks absolutely phenomenal. I've not had chance to really play with it or look at it yet, but um, everything's changing so fast, as I keep telling you. This looks an amazing piece of software. Anthropic, who have the most popular code system at the moment, code generation system, vibe coding system, Claude Code, uh, have just announced a new addition to it called Claude Code Review. And what this does is it takes the job of a senior software engineer and it reevaluates the code and puts comments in and documents the code and reorganizes it so that it can be used by other people. It does the job of it, so it doesn't only write the code, it then reorganizes the code to be used by other people. Um, so as people are saying, it undermines senior engineers. It's now doing the job of. So we're not only doing entry level coding, we're now doing this. Apparently, does more senior level coding work, and that just came out. I don't know, 2 or 3 days ago, March 11th. So yeah, a week ago. Uh, Another astonishing tool from Anthropic. They now have inline visualizations. And this is where, if you were chatting with someone, say over Discord about work, or you're trying to explain something, it can generate real time graphics to help explain what you're talking about. So imagine me as a professor, I'm talking to you right now. you could have real-time graphics appearing explaining what I'm talking about, generated by AI. Again, I haven't had time to look at this. It only came out last week. It just sounds mental, absolutely insane. But yeah, that came out last week. Uh, the web has been full of information about DeepSeek. We're going to be talking about DeepSeek in this module. DeepSeek is a Chinese LLM that came out in January 2025. Well, a version that came out in 2025. There were previous versions, but the R1 version that came out in 2025 kind of turned the world of AI on its head because all of a sudden there was a free LLM that was as good as OpenAI, Gemini, Grok, Meta, Claude, all of these others, and apparently the new version of DeepSeek is going to be released within the next week or two. It will be free again, and they're claiming it's better than all the stuff that's out right now. This is because something called the mixture of experts model they use, and again, we'll be talking about that in this module. Um, This is something I missed. It was at the World Mobile Congress. This was actually about 2 weeks ago. Lenovo, who mainly make laptops and things, announced a bunch of new AI integration in their technology. I didn't really look at it much, but I saw this other story on it, and it caught my eye that they've got this thing called Quira, Qira, that they're rolling out on all their products. And what Quira is, it's a personal ambient intelligence system that goes across all your devices. So you'll have it on your cell phone, your laptop, your tablet, your smart TV, your RoboVac will connect to everything will connect to this Quira system. And this thing will learn about you and then will interrupt and give you advice when you need it. It sounds horrendous because remember the last time a company tried to build something like this was Mr. fucking Clippy, one of the most hated things ever. Microsoft introduced this into their Office suite of projects, and when you're working, Clippy would pop up and say, "Oh, it looks like you're writing a letter. Let me help you do this." And it was the most irritating thing ever. And Lenovo are building Mr. Clippy with AI. So yeah, I'm really skeptical about this one, but who am I? Who am I to judge it? Maybe a success. Uh, Meta and Apple. I don't know what's going on with Meta and Apple. Um, they have no news on AI, hardly anything. They seem to have really dropped the ball here. All these other companies, IBM, Microsoft, Google, OpenAI, all these big companies are just leaning and pouring everything into AI. And Meta seems the only news from Meta is that Zuckerberg's building an AI agent to help him be CEO. Well, bully for him. I mean, what is the company doing with AI? Just don't know. Same with Apple. We've got a few bits of speculation. We'll see. We don't know. Anyway, the other news from Meta are planning to lay off over the next 18 months 20% of their workforce. 20%. And they claim it's due to AI. Every week I'm giving you more bad news on tech company layoffs, but it's just not stopping. Citibank announced they're letting go 20,000 people due to AI. Intel, the chip manufacturer, is reducing its workforce by 15,000. Again, they claim it's due to AI. Crypto.com, 12% of their workforce. They're one of the biggest crypto traders and web organizations. WiseTech is dropping 2,000 jobs. They're one of the biggest software developers in the world. Interestingly, they say because the era of people writing code has ended. No one's ever going to write code anymore. It's all AI, so they're losing 2,000 jobs. this particular headline, I don't really know the implication of this one. I'm not an economist and I don't really understand all the intricacies of the job market, etc. But Jerome Powell, the head of the Fed, recently announced just last week that American job creation has hit zero, which is apparently it's never happened before. Um, I don't really know what the implications of that are, but it doesn't sound good. As I said, I intend to do a whole class or two on future employment and how the workforce is going to change within this module. But, that doesn't look promising, does it? Uh, Lastly, a couple of just weird tech things. Um, Peter Thiel, a very famous venture capitalist, is investing $2 billion in this company that does AI cow collars. Apparently, you put these collars on a cow and it controls the cow. The cow, you don't need fences because it stops the cow going in certain areas. You can keep it fenced in, and it tells the cow when food's ready and stuff like that, and sends it for milking and does it controls the cow. You suddenly don't need all the people to look after the cows. The cows organise themselves. Apparently, he's investing. I never thought AI would be used for this, but why not? Interesting application there. Um, and this is a interesting headline. This is in China. It was a group from Alibaba, which is the Chinese equivalent of Google. They'd built these AI agents to optimize revenue within one part of Alibaba, and it was an experimental agent they were trying, and it actually broke out onto the internet from its testing environment. It hacked in through back doors into other systems and started mining crypto on those systems. Now its kind of parameters told it to kind of optimize money, so that was a way it found it could earn money, which is kind of interesting. I mean, when you read the full article, it sounds like AI going rogue and completely going crazy, but it actually did what it was told to do, really. But yeah, it's an interesting example of this. These things that AI, the people who are quite pessimistic about AI are saying right now, people like Jeffrey Hinton, it's not that AI will destroy the world or take over everything and, just make us extinct. It's that we have to look at problems now where AI passes its boundaries and starts doing things we don't expect that are going to cause real issues. And if we don't tackle that now, it's going to cause bigger issues in the future. So that's what most of these experts are saying. And this is a prime example of that, the kind of thing they're talking about. Okay, so that's the news items that we've got at the moment. Let's let me set up my computer and then I'll carry on and tell you all about we'll start looking at LLMs. So, so far, the course has dealt with mainly the theory. So we've been looking at definitions of transhumanism and lots of other things. We've considered philosophy, um, in particular Nietzsche and consciousness, which we'll need as we start looking at the implications of AI in the future. And we've gone through a lot of the technology, and in particular the history of the technology and definitions of AI to move to where we are now. Most of the rest of the course is going to be looking at future implications of AI on the workforce, on relationships, on the economy, the ethics of what we're dealing with here with AI and what's going to change, trying to make some predictions and trying to prepare ourselves for it. And we'll talk about whether AI is going to kill us all or not as well. But where we are now is we're at that moment in this course. There's a module 5, which is on large language models and agents. And what that does is for the next two, maybe three classes, we're going to look at where we are right now, which is pretty scary in itself, to be honest. As I just showed you, it's impossible to keep up with where we are now. I'm going to show you we're going to focus on what's happened in the last 7 years, 6, 7 years, and move us up to where we are now. Uh, this will involve, so let's have a look at Brightspace. What we have on Brightspace is this module which has popped up on there, large language models. You'll see there's 2 pages of information, one on large language models and one on AI agents. And there's also a worksheet, worksheet 6. This is a fairly small worksheet, only worth 10 marks. And what this worksheet only has 3 questions. The first 2 questions you kind of do in class. So those of you online, as you watch this video, make notes in these on these 2 questions. And the last question is the usual reflection on your learning and why do you think what you've learned is important and what are the implications of it. So I'm going to be showing you how these large language models work, which is quite important to know in today's society. And the question I want you to focus on question 1, so take notes, is why and how are these new large language models different to what the AI systems we've had in the past? And then, kind of by the end of the section, when we've covered all of the learning about LLMs and specifically about AI agents, I want you to try and look back over what you've learnt in this couple of lectures, and what were the trends? What is happening in trends, and what's the implication of those trends? What is coming for the future? So, grad students, of course, I expect you to do a little bit more. I expect you to do some of your own research on this as well, and try and give me some references of things you've read or looked up. Um, Undergrads, you'll probably have enough from the lectures to do this, but if you want really high marks, do explore other things. All right, so let's get started. So we're going to start by talking about uh, uh, LLMs and agents in this module. This is really about artificial intelligence and where we are now. I'm going to tell you about large language models and how they work, which involves you knowing how the transformer model works. And we're going to use ChatGPT or OpenAI's LLMs as the example of this, of how these things have developed over the last 8 or 9 years. There are some extra slides in here that were not created by me. They were created by John Linstead, who used to be a professor here at Oswego. He allowed me to use the slides. He used to teach this part of for one semester, he taught part of this course with me. We ran it together. So let's get started. Before we start, I want to add a couple of definitions. These are things I've talked about already, but we're going to be this terms these terms are going to crop up a lot. So I've talked a lot about tipping points with technology. It's a tipping point is a critical point in a situation, process, or system beyond which a significant and often unstoppable effect or change takes place. So think about pushing a ball uphill. You hit a tipping point. at the top of the hill. It's a moment of small influence. You don't have to push it far, but then you can't stop it. It starts rolling down the hill. So a significant change takes place, often unstoppable. You just hit this point. Disruptive technology, technology that creates a new market or value network or enters at the bottom of an existing market and eventually displaces the existing technology or the market leading firms and products. Um, think about music. Everyone had cassettes and vinyl. Then CDs came out. No one bought cassettes anymore. There was a tipping point when we switched to CDs. It was a disruptive innovation. It got rid of cassettes. Now we all have digital music. Who buy CDs anymore? Again, they're a dead technology. We all have digital music now. Of course, there are vinyl collectors, and the only people who buy cassettes are hipsters these days. So there are lots of disruptive technologies, Internet of Things, renewable energy, AI, and we're going to be focusing on the tipping point and disruptive effects of AI technology in this section. But to give you an example of what I mean, let's look at Netflix as a disruptive technology. Back in the early 80s, Blockbuster started, and we went to a store to rent videotapes, VHS videotapes. Video rental services came in the late 80s, early 90s. By 1994, Blockbuster was valued at $8.4 billion. Netflix came in about 1997, and their new innovation was it was a mailing technology where discs came in the mail. You ordered a particular movie, it came in the mail, and you posted it back. And that meant you didn't have to go to the store anymore. And it disrupted Blockbuster. And there was a point when the DVD mailing service there was a tipping point, which is this middle yellow dot, which disrupted the Blockbuster model. And we moved into this mailing model. But going along with that, we have the development of video on demand services. Uh, you may not know this, but the primary driver of video on demand was pornography. We wouldn't have YouTube and all these video on demand streaming services without. The first big video servers were pornography servers. It drove the technology. Um, but by 2007, 2010, we start to see streaming becoming mainstream, and Netflix starts offering movies over streaming. Other streaming services come online, and this upper yellow point is where the tipping point is, where we switch from a mail system to a streaming online system. And by 2020, Netflix is valued at over $200 billion. And again, who mails off for a DVD or Blu-ray anymore? Nobody. Um, we all use streaming services. Tipping points to disruptive technology. So just be aware of these two definitions as we move on through this through this presentation and showing you about the impact of AI. Let me just pause for a so uh, obviously you're in this course, you're studying this subject, so you're at least partially clued in by now what's going on. We're experiencing a very, very rapid expansion and evolution of technology centered on AI, incredibly fast. But it's also the case that AI has been around for quite a long time. So, is there something different? Is it a big deal? This is the question I want you to look at question one on the worksheet. So, we're going to look at the history of AI, but when I say history, we're not going past 2017, is as far back as we're going here. We're mainly looking at what's happened from 2017. So, how AI has shown up more in the world in recent years. And we're going to explain why we've gone over this tipping point and disruptive. AI has become disruptive. So, uh, definitions again, things we've been talking about. We have definitions for AI about intelligent agents in the environment, but John here on one of his slides says if a system any system that involves a system making some sort of informed or intelligent decision, understanding context and its environment beyond simple inputs is kind of AI. Yeah, that's a kind of decent definition. But different types of AI we've come across. Remember symbolic AI. Remember the early stuff. Um, the early AI was symbolic reasoning, the expert systems. These are all top-down systems, remember, putting knowledge into a machine. But these were the early systems, but now top-down has come back with a vengeance. So we're looking at a lot of symbolic AI at the moment again, these neurosymbolic systems. Remember, this third wave of AI that we're in now, that started in the early 2000s, is machine learning, where we're using mathematics and statistics and neural networks to recognize patterns. So, recognize if an email is spam or not, whether we're looking at a picture of a cat or a dog. So, things like that. And machine learning is generally run by a neural network, which is a computer modeled on the human brain where we have artificial neurons that mimic the human neurons. We pass information through, see if it's right, and then go back and adjust the weights between those neurons. So these are things we've seen before, but I've got two new terms for you now, two new definitions. Generative AI. A generative AI system is one that goes beyond pattern recognition. So this is a difference. Goes into more complex abstractions, and we're going to be talking about those abstractions. So it can be allows it to be combined the trained information in novel ways, in ways we haven't seen before. This means to get this, to get generative AI, you need scale and complexity. You need big systems to capture all the complexities of what's going on. So these large language models like the GPT models are generative AI. They're big. But there's another term for you here, conversational AI. These are AI systems that use the concept of natural language, a natural language interface. So you can talk to them, you can have a conversation with them. This is not easy. It takes a lot of work to switch from a normal AI model, like a generative AI model, to a conversation model. You have to rebuild the model and you have to fine tune it a lot, and you have to put a lot of symbolic logic into it as well before it will work as a conversational model. So, let's look at the last 15 years from 2010. From 2010, we saw that AI was already everywhere. We'd already done that, but it was piecemeal. It was small, little, dedicated, focused systems. We're going to look at what happened in leading up to 2020 And then this period between 20 and 22 where we hit the tipping point, where AI suddenly became more ubiquitous and everywhere. And that's like art generate. We started to generate images. People started to use Chat GPT, and we're going to be talking about that. But there was an even bigger event two events in 2003 that changed everything again. We thought we'd gone past the tipping point, but then we had another tipping point. And we're going to talk about that tipping point as well in March 2023. We had a paradigm shift in our generative models, where models were debugging their own code. And we also had some leak models to the public, and we'll talk about how those things change the world. So, 2010, we've already mentioned a lot of these, but we had smartphone assistants like Siri and Alexa, but they weren't really smart. You didn't have conversations with them. You gave them instructions. We had the recommender systems coming up from Netflix and Amazon and getting better. They worked on social media as well. We have customer service chatbots, but if you've ever been on the phone to a bank and talked to these things, they're not very good. We started to have autonomous vehicles, AI in vehicles, so it stays within lanes. Even a car that's not fully autonomous now has technology that keeps it in lanes, and that was starting to come out. We had the machine learning stuff like detecting spam email. We were starting to get language translation pretty good on AI systems. Still not great, but it was working okay. Excuse me. AI diagnostic systems. Remember, these expert systems have been used in medicine since the 1980s and 90s. They were still around, getting better, still being used. Machine learning systems for stock trading, finance, all there. Video games, I showed you the genetic algorithm stuff, but all of the NPC characters are now generally governed by AI, often symbolic AI, but there's machine learning stuff as well. But you may not realize this, we also had autocomplete that finishes sentences for you. When you're typing into Google, it predicts what the next word is. Out of all of those, you may not realize, but what's the most important one? You may not realize this, but it is autocomplete by far. That autocomplete technology is the basis for all of the generative AI systems we have today, and I'm going to show you why. So, we got past that and we're coming up to the late 2010s. And we start to hit 2020 and these large language models start to appear. The large language models are based on one specific innovation, which is called the transformer model. And I'm going to be showing you how that transformer model works in a moment. This is the spark. This is what suddenly opened up a new world, this transformer model. We could start building. The transformer model allowed us to build bigger AI systems. We could scale them. And OpenAI really was the first company. It wasn't a company at the time when it first started, but it was the first organization to start to really see what the transformer model could do. Once they had something powerful, they switched it to a conversational AI. They changed it from GPT to Chat GPT, and they added a natural language interface. It became conversational AI as opposed to generative AI. And that was the tipping point. So we're going to look at how that worked. So this is a brief history of large language models. If you look on Brightspace, there are some documents on history of LLMs. There's also definition articles with lists of definitions if you don't understand anything. Those are useful background stuff that might help you with the worksheet. But I've been teaching this course for 10 years, this transhumanism course. And I watched transformer models appear. I saw GPT-1 appear in 2018. And I was standing in this class telling students that nothing would ever be the same again. This is going to change the whole world. You're going to see everything just completely change. This transhumanist idea of what's going to happen to humans and society. And I often felt like Cassandra. If you don't know who Cassandra is, she's a famous mythological figure from ancient Greece. And she had a magical gift and she was also cursed. Her magical gift was that she could see the future and knew what was going to happen. Her curse was that no one ever believed her prophecies. So she always knew what was going to happen, but watched everyone do the wrong thing because they didn't believe her. And I felt like that because no one believed me that this is coming, this is going to change. And it's actually happened a lot faster than I predicted. I was not predicting where we are now till 2040 or so, 2035, 2040. So it's happening a lot faster than I predicted, but it's happening. So uh, let's go back to 2017. What happened in 2017? Google researchers created this thing called the transformer model, which completely changed, uh, how we see the world in artificial intelligence. Okay, so let's have a look at this transformer model. Well, I've already shown you neural networks and how they work. The transformer model is a neural network model. So this is a neural network for predicting the magnitude of an earthquake. You see on the left-hand side, the inputs. I tell it where the earthquake happened, longitude and latitude. I tell it how long the earthquake lasted. I tell it the force involved and the seismic energy, and it gives me the magnitude on the Richter scale out the other end. And I train this network by showing it thousands and thousands of past earthquakes, seeing if it gets the right prediction. If it's wrong, it goes back and alters these W values, the weights between the neurons or nodes, until it is getting the right answer almost all the time, and then we start using it and it becomes a predictor. Transformer models are exactly the same. They're a neural network, but they're a lot bigger. This is a picture of the transformer model. Don't worry about it. You don't need to learn how it works. That's way beyond learning how this neural network works is beyond the scope of uh, this class. But I do want you to know the differences between this model and the previous model, which is what I'm asking you to write about in question one, really. So neural networks have always been continually developing. We've had feed-forward neural networks, we've had back-propagation neural networks, we've had recurrent neural network, all these different types. And in 2017, these guys from Google, these folks from Google came up with the transformer model. And this was the turning point. So what's different about the transformer model? Three things. Firstly, it has a parallel design. Most models take in one piece of information at a time, like one word in a sentence. So if you're trying to do stuff on a sentence, you're reading in one word at a time. The transformer model works in parallel and takes in all the text at once. So to train the model, when you get to these huge models that are millions of nodes, to train them would have taken centuries. All of a sudden, we can now train them in a few weeks. That changes everything. We go from quite small models to suddenly we can build big ones. This means it's scalable. Another thing that works in our favor is we now have, even in 2017, we have lots of data centers. We can buy cloud computing resources. At the time, it was mainly from Amazon who were running these. You could buy computer power, massive amounts of computer power, which can train these enormous AI. So we've got parallel design, we've got scalability, but the thing that they call, in AI terms, they call this the magic sparkle attention mechanism. This is the real crux of the thing, why this thing is different. And you'll have to excuse me. Oh, I'm a bit sniffly today. Oh. So the thing that explains this is the attention mechanism. The magic, like I said, they call it in AI circles. This is called the magic sparkle that makes large language models what they are. It's really hard to explain, but I'm going to be trying to explain it over these next couple of lectures. I'll be trying to show you what it does. But it's a crucial idea. Words change with context. I know I've used this example before, but if I ask you how fast is a jaguar, it's a different question if we're in a zoo or if we're in a car showroom. I'm talking about the jaguar car or the jaguar animal. And you'd immediately know that, but the AI system doesn't. The attention mechanism allows the AI to understand the context. So now AI is gaining understanding, not just think of the Chinese room experiment. It's not just processing symbols according to rules anymore. It's understanding the context. So every word's meaning is affected by others, and the AI can understand this. The other thing is nuance, like the words come here. I can shout it angrily or I can say it lovingly. But the words are the same, but the context is different. But AI can now start to understand when you're angry or when you're in love with someone. This nuanced understanding, which is beyond the words, which is what humans do, higher levels of cognitive processing. So it's starting to understand all these things. And this is the most curious bit, but we're not going to go into it right now. I'm going to show you some of this as we get on. As we come into the later models, you'll start to see how absolutely astonishing this magic sparkle of attention mechanism is. Okay, so I'm going to play you a video which will explain how the transformer model works. Honestly, this allows you, watching this video kind of changes how, if you don't know anything about large language models, it will change how you think about them because they are just a neural network. They're a big neural network, but they are just a neural network. And you will see how they are giving the answers when you type on that. It seems like magic. You type a prompt and you ask it to do something and it comes back with this fully written essay. How is it doing that? This will explain how it does it. So you'll have that knowledge. It is a bit of a long video. It's about 6 minutes, but it's really great and explains it, as I said, way better than I could. So we're going to now watch this video. Let me open up the video. No, not that one. That one. Okay. Oh. Okay. Larger language models.
Imagine you happen across a short movie script that describes a scene between a person and their AI assistant. The script has what the person asks the AI, but the AI's response has been torn off. Suppose you also have this powerful magical machine that can take any text and provide a sensible prediction of what word comes next. You could then finish the script by feeding in what you have to the machine, seeing what it would predict to start the AI's answer, and then repeating this over and over with a growing script completing the dialogue. When you interact with a chatbot, this is exactly what's happening. A large language model is a sophisticated mathematical function that predicts what word comes next for any piece of text. Instead of predicting one word with certainty, though, what it does is assign a probability to all possible next words. To build a chatbot, what you do is lay out some text that describes an interaction between a user and a hypothetical AI assistant. You add on whatever the user types in as the first part of that interaction, and then you have the model repeatedly predict the next word that such a hypothetical AI assistant would say in response, and that's what's presented to the user. In doing this, the output tends to look a lot more natural if you allow it to select less likely words along the way at random. So what this means is even though the model itself is deterministic, a given prompt typically gives a different answer each time it's run. Models learn how to make these predictions by processing an enormous amount of text, typically pulled from the internet. For a standard human to read the amount of text that was used to train GPT-3, for example, if they read nonstop 24/7, it would take over 2,600 years. Larger models since then train on much, much more. You can think of training a little bit like tuning the dials on a big machine. The way that a language model behaves is entirely determined by these many different continuous values, usually called parameters or weights. Changing those parameters will change the probabilities that the model gives for the next word on a given input. What puts the large in large language model is how they can have hundreds of billions of these parameters. No human ever deliberately sets those parameters. Instead, they begin at random, meaning the model just outputs gibberish, but they're repeatedly refined based on many example pieces of text. One of these training examples could be just a handful of words, or it could be thousands, but in either case, the way this works is to pass in all but the last word from that example into the model and compare the prediction that it makes with the true last word from the example. An algorithm called backpropagation is used to tweak all of the parameters in such a way that it makes the model a little more likely to choose the true last word and a little less likely to choose all the others. When you do this for many, many trillions of examples, not only does the model start to give more accurate predictions on the training data, but it also starts to make more reasonable predictions on text that it's never seen before. Given the huge number of parameters and the enormous amount of training data, the scale of computation involved in training a large language model is mind-boggling. To illustrate, imagine that you could perform 1 billion additions and multiplications every single second. How long do you think that it would take for you to do all of the operations involved in training the largest language models? Do you think it would take a year? Maybe something like 10,000 years? The answer is actually much more than that. It's well over 100 million years. This is only part of the story, though. This whole process is called pre-training. The goal of auto-completing a random passage of text from the internet is very different from the goal of being a good AI assistant. To address this, chatbots undergo another type of training, just as important, called reinforcement learning with human feedback. Workers flag unhelpful or problematic predictions, and their corrections further change the model's parameters, making them more likely to give predictions that users prefer. Looking back at the pre-training though, this staggering amount of computation is only made possible by using special computer chips that are optimized for running many, many operations in parallel, known as GPUs. However, not all language models can be easily parallelized. Prior to 2017, most language models would process text one word at a time. But then, a team of researchers at Google introduced a new model known as the transformer. Transformers don't read text from the start to the finish. They soak it all in at once, in parallel. The very first step inside a transformer, and most other language models for that matter, is to associate each word with a long list of numbers. The reason for this is that the training process only works with continuous values, so you have to somehow encode language using numbers, and each of these list of numbers may somehow encode the meaning of the corresponding word. What makes transformers unique is their reliance on a special operation known as attention. This operation gives all of these lists of numbers a chance to talk to one another and refine the meanings that they encode based on the context around, all done in parallel. For example, the numbers encoding the word bank might be changed based on the context surrounding it to somehow encode the more specific notion of a riverbank. Transformers typically also include a second type of operation known as a feed-forward neural network, and this gives the model extra capacity to store more patterns about language learned during training. All of this data repeatedly flows through many different iterations of these two fundamental operations, and as it does so, the hope is that each list of numbers is enriched to encode whatever information might be needed to make an accurate prediction of what word follows in the passage. At the end, one final function is performed on the last vector in this sequence, which now has had a chance to be influenced by all the other context from the input text, as well as everything the model learned during training, to produce a prediction of the next word. Again, the model's prediction looks like a probability for every possible next word. Although researchers design the framework for how each of these steps work, it's important to understand that the specific behavior is an emergent phenomenon based on how those hundreds of billions of parameters are tuned during training. This makes it incredibly challenging to determine why the model makes the exact predictions that it does. What you can see is that when you use large language model predictions to autocomplete a prompt, the words that it generates are uncannily fluent, fascinating, and even useful.
I think that video is fantastic. It really explains what's going on in there. One of the key things is this idea of the attention mechanism making the LLM an emergent phenomena, the kind of understanding of context and the things it does grows out of its training. It emerges. And the people who were building these LLMs in the early days, even now, as they build a new one, they don't know what it's going to be able to do until they build it and then they find out. And that's what this history of AI has all been about. So let's look at where we are. So 2017, the transformer model appeared. Google researchers built the first transformer model, and this company, OpenAI, jumped on it. And well, they weren't a company then, but they jumped on it and started to build generative models using the transformer model. So, as I said, we're going to use OpenAI as our example of what has happened over the years. But this is true for most companies who are in this space. They've all followed the same kind of evolution pattern. But OpenAI were the first, so we use those. At the time, they were a venture capital funded research foundation. They weren't a company. The idea was this new technology held great promise, but no one knew what it was capable of. So they get the transformer model. They know they can process a lot of data. They know they can rent a lot of cloud computing resources. They get a stack of money from venture capitalists, and they've no idea what this attention mechanism will do, but they want to see what it can do. So that's the innovation. They're just hoping it does something useful. So, but that's why they were a research foundation, not a company. So they're banking on this massive amount of complexity, which we've never had before, because we've got the parallel systems, we've got the cloud computing resources, we can scale up the model, and we've got this attention mechanism. Let's see what happens. So they start to build their first model and they call it the Generative Pre-trained Transformer, GPT. Takes them a year to build this, and they have 117 million neurons, bigger than any neural network that had ever been built before. So they've got this enormous neural network. First one, they call it GPT-1 or just GPT, and they start testing what it can do. And it's okay. It can comprehend text patterns, so it can finish sentences like autocomplete does. But unlike autocomplete, it's not Googling an answer. It's not looking for an answer on the web and seeing what the most popular answer is. It knows in its own brain, if you like, what the text is. It's learnt it. So it's got some comprehension of text, this AI system. It can answer some simple questions and it can translate languages, but not very well. But it can do some translation between English and German and things like that, but fairly simplistically. And you were like, okay, that's pretty promising. So they keep going. A year later, they bring out GPT-2. This is over 100 times bigger. 1.5 billion neurons. So they've now got much more computing space. They've got a much bigger neural network, huge. And what they start to see is it really understands the text now. It knows what's going on and it can handle context. So when you're talking to it, it understands what you're talking about. A jaguar in a zoo or a jaguar in a car showroom. It understands what's going on. But they didn't expect this, but all of a sudden it could write stories. This was a complete shock to everyone. You type in a shocking finding, scientists discovered a herd of unicorns, and it finishes the story saying, living in a remote, previously unexplored valley in the Andes Mountains. Even more surprisingly to the researchers was the fact that the unicorn spoke perfect English. So it's almost adding little humorous bits, and it's this is a frigging Turing test. The thing is behaving like a human, finishing sentences. And the more things they tested it with, the better it was. They were completely blown away. That magic sparkle, the attention mechanism, really was doing. They didn't know what it would do, but it was doing it. It was suddenly doing something. So they got more money from venture capitalists, and boom, 2020, they came out with GPT-3. Again, way over 100 times bigger again. This one had 175 billion neurons. Now, this thing had deep understanding. It understood nuances in language, whether you were angry or sad or loving. Uh, all of a sudden, it could write complete essays. It could solve complex problems and engage in human-like conversation. For the first time, it was able to generate computer code. It was able to start programming um, with little to no instruction. And it can do multi-step reasoning. It could solve a complex problem by breaking it into smaller tasks and solving it. This thing, again, they didn't know what to expect, but it was amazing. But all of these, like I said, this was like a public Turing test. All of these, because they were a research foundation, they put out publicly. You could just go to a web browser and play in GPT-1, GPT-2, GPT-3. In my classes in 4 or 5 years ago, this is what we were doing in class. We were playing with these models. They were free models. And you could go in and use them. But look at the side. You could vary which learning model you used, and you could alter the amount of randomness in the model, or how it was answering things, or how much you could put into the model. So all of this was kind of in there, and the models were open, and you could play with them. They were great research tools. It was fabulous. Like I said, a bit Wild West. These were brand new. No one knew what they could do. One more definition for you. A token. A token is basically a piece of text. It can be one character or one word. And tokens are what you put into an AI system to ask a question or a query. So GPT-1 only allowed you to use about 10, 15 tokens. You could only put one sentence into it to start it going. And it increased a bit. By GPT-3, you could put about 20, 50 tokens in. Um, and you could start to buy extra time on the model where they would sell you tokens so that you could use the model more. And this was how they were selling time on the machines at the time. So a paragraph was about 50 tokens if you put that into the AI system. So, and this is where it started hitting the public a little bit. We start to move towards that tipping point. College students are suddenly using it to write their essays. All of a sudden, we're starting to see articles appearing, journalism written by GPT. We, 2019, we saw the first computer science paper published in a respected computer science journal that was written by GPT-3. It had human help. Human computer scientists helped it and cleaned it up, but the article was written by GPT. So GPT-3 was the main author of the article. So all of a sudden, we're in this new world where these things can do all these human tasks. So we're up here at May 2020 when GPT-3 came out. And what we start to see is all the press and the public are starting to take interest in this now because it's useful. Um, so if you look at as I said, the large transformer model page has stuff on the history of LLMs, definitions, but look at this Race to Understand Language article from MIT. This is the kind of thing that was coming out in 2020, 2021. And, the newspapers and the TV, everyone's starting to realize that this race is going on. All these big companies are now making these large language models. And so Lambda from Meta, they talk about Lambda and how Google was using Lambda because they hadn't built their Gemini models yet. We got Microsoft licensing GPT-3 to go in their stuff. So all these huge technology companies are now fighting to use all these different models. So we see that coming up. They talk about this company called Cohere, which you may remember hearing about before, which had just started up in 2021. That's the company that I mentioned 2 weeks ago. NVIDIA gave them $100 billion to form a partnership with them. So, yeah, these companies are still going. Um, so, yeah, uh, the AI marketplace, it just starts going crazy in 2021, again, towards its tipping point. But the tipping point isn't really here yet. What happened to cause the tipping point was something else. You see, 2 years later, in 2022, GPT 3.5 came out, and this is the tipping point. Why? Because GPT 3.5 was what you probably know as ChatGPT. They changed the name. It was still the GPT-3 model. It had 175 billion neurons. They didn't make it any bigger. But, so it's the same thing. We're seeing what OpenAI do. They've been scaling up these things and seeing what happened. But with GPT-3, they had something. So what they did was they made it usable. HCI, they put an interface on the front, a natural language processor, natural language interface. They called it ChatGPT, and you could talk to it. That took them 2 years to do. Like I said, switching from a generative AI system to a conversational AI system is not easy. Excuse me. I think I'm going to sneeze. No, no, no. Oh, sorry, my house is very dusty. I'm having renovations, so I'm sneezing a lot. Anyway, so we got Chat GPT appearing in 2022. This is the tipping point. Two big things they changed. They made it faster and cheaper. So it's the same size model, but it's faster and cheaper. They offered it for free so everyone would use it. And it was fine-tuned to engage in conversations. That was the other thing they changed. So if you type, hey, it doesn't try to finish the sentence. It comes back and says, hey, hi there, how can I help you today? It has a conversation. That was the extra kind of level of training they had to give it so that it would have these conversations, turn it into a conversational interface. We can't overstate how important that was. Usability is everything. A few people were using ChatGPT, some students were using it, all these kind of problems. But as soon as you hit that natural language interface, everybody used it. It became a tipping point that everyone knew what it was, disruptive technology. So this is what we saw. So a recap. We watched one company, OpenAI, pursue a very logical trajectory. Transformer model came out, they kept scaling it up until they got something useful. And they evolved from, wow, that's a bit of a text calculator, it does some cool things, to what the hell did it just do? People couldn't believe what this stuff could do. They didn't know what it was going to do. And as soon as they got to that point where it was writing essays and technical papers and doing all this, they suddenly put ChatGPT, put an interface on it, and put it out in the public. So let's just look. Netflix, as a streaming service, took 5 years to reach 1 million users. Kickstarter, Airbnb, and Twitter took about 3-4 years to reach 1 million users. Facebook, Dropbox, about a year. Instagram took about 2-3 months. ChatGPT, 5 days to reach 1 million users. The very definition of a tipping point, really, a disruptive technology. What we also saw around 2001 was OpenAI released DALL-E, their first image generator, where you could put in a text prompt and generate an image. These work slightly differently. They still use a transformer model, but they work slightly differently. So we're going to watch the start of a video that explains how these work. We're only going to watch, it's a very technical video. We're only going to watch the first 3 or 4 minutes just to get some general idea of how these, what are called diffusion models, work to generate images. So let's have a look at one of those. So give me a second to open this video. You'll see on D2L, there's more information on transformers. There's a more detailed video about transformers if you want to watch that, as well as the video I showed you. But we're going to watch a little bit of this one here. So, which explains how...
Imagine being able to build anything just by thinking about it. Meet Base 44, a complete AI creation platform made for anyone with an idea.
And there we go.
Work in practice and give us some powerful theory for dramatically speeding up image and video.
Let's start that again. Here we go.
Over the last few years, AI systems have become astonishingly good at turning text prompts into videos. At the core of how these models operate is a deep connection to physics. This generation of image and video models works using a process known as diffusion. which is remarkably equivalent to the Brownian motion we see as particles diffuse, but with time run backwards, and in high-dimensional space. As we'll see, this connection to physics is much more than a curiosity. We get real algorithms out of the physics that we can use to generate images and videos. And this perspective will also give us some really nice intuitions for how these models work in practice. But before we dive into this connection, let's get hands-on with a real diffusion model. While the best models are closed source, there are some compelling open source models. This video of an astronaut was generated by an open source model called WAN 2.1. We can add to our prompt and have our astronaut hold a flag, hold a laptop, or hold a meeting. If we cut down our prompt to just an astronaut, we get this. And if we cut down our prompt to nothing, we interestingly still get this video of a woman. If we dig into our WAN model's source code, we'll find that the video generation process begins with this call to a random number generator, creating a video where the pixel intensity values are chosen randomly. Here's what it looks like. From here, this pure noise video is passed into a transformer. This is the same type of AI model used by large language models like ChatGPT. But instead of outputting text, this transformer outputs another video that now looks like this. Still mostly noise, but with some hints of structure. This new video is added to our pure noise video and then passed back into the model again, producing a third video that looks like this. This process is repeated again and again. Here's what the video looks like after 5 iterations, 10, 20, 30, 40, and finally 50. Step by step, our transformer shapes pure noise into incredibly realistic video. But what exactly is the connection to Brownian motion here? And how is our model able to use text input so expressively to shape noise into what our prompt describes? In this video, we'll unpack diffusion models in 3 parts. First, we'll look at a 2021 OpenAI paper and model called CLIP. As we'll see, CLIP is really 2 models, a language model and a vision model, that are trained using a clever learning objective that allows them to learn this really powerful shared space between words and pictures. Experimenting with this space will help us get a feel for the high-dimensional spaces that diffusion models operate in. But learning a shared representation is not enough to generate images. From here, we'll look at the diffusion process itself. At a high level, diffusion models are trained to remove noise from images or videos. However, if you dig into the landmark papers in the field, you'll find that this naive understanding of diffusion really doesn't hold up in practice. In this section, we'll dig into the connection between diffusion models and diffusion processes in physics. This connection will help us understand how these models really work in practice and give us some powerful theory for dramatically speeding up image and video generation. Finally, we'll bring these worlds together and see how approaches like CLIP are combined with diffusion models to condition and guide the generation process towards the videos we ask for in our prompts. 2020 was a landmark.
All right. So that's really as far as we're going to get to today. What you've seen here is we are now up at around 2022, and we've had this tipping point. But what you need to remember is that, as I said, we. Let me go back a little bit. Jump back. That's the one I was looking for, this slide. All right. But what you need to remember is, so we had quite ubiquitous AI, but more standard machine learning stuff up until 2017 when the transformer model developed. We then hit this tipping point with ChatGPT-3, and the tipping point really was when they added the conversational model, which turned it into a huge global phenomenon. But as I said, there's an even bigger tipping point coming up in 2023, and we'll look at that on Thursday in the next class. All right. And then when we get up to date, we'll start looking at AI agents. Just one last thing to mention. the worksheet is quite a small one here. It's the same for the online and in-person students, just two questions to answer. But what I am going to do, what I'm hoping to do, is uh, I'm going to add another extra worksheet and I'm going to have all of you build an AI agent. As I said, this class is a nightmare to teach because things change so fast. When I taught this class a year ago, there were no agents. It was a technology people were talking about, so I was teaching about what was coming with agents and what they were expected to do. And now we live in this world where everything is agentic. I am I am going to teach you about agents, and I've decided to get you to do something. This is really a theoretical class, but I want to teach you a kind of practical skill to build some simple agents. You can build something that works for you, that helps you. Um, you don't need any coding knowledge or anything like that. This is all what the kind of vibe coding stuff. Um, but we're going to build, I'm going to get you all to build an agent and do some sort of evaluation. So worksheet 7 will be appearing soon for you to build an agent, which, like I say, will be useful, hopefully useful for all of you that you can now build agents that help you in your day-to-day work. Okie dokie. That's it for today.